Okay. So I may not have gotten the right answers all the way through, so if you find something that's wrong, please correct me and we can go back and look at the answers again. If you get an answer that's not the same answer that I got, and I graded these fairly quickly. If you disagree and you disagree strongly and you can prove it, I'm willing to look at your answers. So again, I don't have a magic bullet like I've got a textbook or anything like that. I just work through them like you did, and hopefully that this will. Okay, so we got to go pretty fast in order to get through this. Okay, so we got to look at the voltage, or excuse me, the resistance. So V equals IR, and this we got to find the R, and the R is the 1/4 plus 1/1S plus 1/4/S or S/4. Everybody agree with that? Now you got to solve this. You got to get a common denominator, in this is equal to 1/S/4S plus 4/4S plus S squared over 4S. Okay? So that's the first step. Okay, so that gives you step one. Now, the denominator is the numerator. So So the denominator is the numerator. So basically now you've got 4S over S squared plus S plus 4. Now that is my R, okay? My I is equal to what? 4 over S. So you multiply this by 4 over S. Now this is equal to my voltage, right? And that's what you now have to convert back to. Now you play the game of converting from the S domain back to the time domain. So basically you can cancel out this, cancel out that. So it's equal to 16 over S squared plus S plus 4. Now you use the quadratic equation and you get what? It's equal to 16 over S plus a half plus 1.936J plus, excuse me, that times S plus a half minus 1.936J. That's where you should have been, okay? Now, you solve this is equal to K over S plus a half plus 1.936J plus K star over a half, excuse me, S plus a half minus 1.936J. All right, so now you say 16, so you is equal to K times S plus a half minus 1.936J plus K star times S plus a half plus 1.936J. Let S equal minus a half minus 1.936J. 16 is equal to k times 2 times minus 1.936j, okay? K is equal to 16 over 3.872j, which is equal to 4.132 at angle 90 degrees. So V of t is equal to 2 times 4.132 e to the minus 1/2 t cosine of 1.936t minus or plus, doesn't really matter, minus 90 degrees or plus 90 degrees, okay? Any questions about that? Piece of cake, right? Okay, any questions about number 1? Number 2. Same song, same verse, and I'm sorry, Mr. Leo, I told you wrong. It's over s squared. It's over s 6 over s squared for this one. I thought it was the delta, but it's the wrong. I went the wrong way, and I told you wrong. So again, see me afterwards if you want more points. Okay, for this number 2. I was not doing well. I hate to use that as an excuse, but I was feeling punk on Monday. So again, this is the same question, except for now, instead of, it's 6 over s squared for my I, okay? So now we play the same game with the these 3, and we get 10s over 5s squared plus 2s plus 10. So this is our r, okay? So okay, and it's that times times 6 over s squared. Okay, so we now cancel, we start doing some cancellations, and we do the binomial, or the quadratic equation, but we have to get this to, we want to get this to 1s squared. So basically we cancel this. We say it's 2s over s squared plus 2/5 s plus 2 times 6 over s squared, and we cancel that. So now we've got an s. We got we got 12 here, okay? It's 12 over s times s plus 1/5 plus 7/5 j. This is a 12. I missed that in my calculation, so my numbers are going to be off a little bit, okay? So anyway, so it's going to be that times s plus 1/2 minus 7/5 j, okay? All right? So it's equal to, this is equal to a over s plus k over s plus 1/5 plus 7/5 j plus k star over s plus 1/5 minus 7/5 j. Now, this is as far as I got it. I missed this right here. It should be 12, okay? Did anybody get 12 over that? Huh? Did anybody get that? Did anybody follow this through and finish this off? Okay, well, if you got to this point, you should be able to finish it off. But basically, this is as far as I got it. Okay? Any questions about that one? All right. Well, I'm going to go ahead. I missed the last piece of this one, so anyway, but at least you got most of it. Okay. Okay, number three. Number three. This one is this one's so now we have to combine these two. So now we have to combine these two into one. So what's the best way to do that? If it's 3, you can't do R1, R2. But if it's 2, you can use the R1, R2 over R1 plus R2 rule. Okay? So it's 2 times what? 4 over S over 2 plus 4 over S. So now you've got to find, so it's 8 over S over 2S plus 4 over S. Does everybody see that? Those cancel. So this is equal to, you can cancel the 8, it becomes a 4 over S plus 2. Everybody agree with that? So the resistance of this guy is 4 over S plus 2. So what is voltage across the output? V out is equal to what? Voltage divider. It's that 4 over S plus 2 over 4 over S plus 2 plus 4 plus S times 5 over S. And that's it. Now, once you've got that far, it's just combining stuff and getting stuff in its order, right? So now you've got to find, so you've got to get 4 plus S times S plus 2, because that's what you got to do in order to find the denominator, get a common denominator for this whole thing. You got to get a common denominator here, all right? So you got to get 4 plus S times S over S plus 2. If you multiply by 1, if you multiply by S plus 2 in the numerator and the denominator, you've not changed this. So now you've got to say 4 plus S times S plus 2 and put it in here, and then you've got a common denominator, and you can cancel denominators. So what is this? You got to say 4 is equal to what? 4S plus 8 plus S squared plus 2S. Okay, plus 2S. Does everybody agree with that? It's 4s plus 8 plus s squared plus 2s. So you combine this and you get s squared plus 6s plus 8. So now you can go down here and you can write 4 over s plus 2 over 4 plus s squared plus 6s plus 8 over s plus 2. Denominators go. Now I've got 4 over, what do I have? I have s squared plus 6s plus 12. Everybody agree with that? That whole thing times what? Times 5 over s. What have I got? Quadratic equation. I've got an a. I've got an a over s plus k da 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 da. And that's how you find. Does this sound like a recurring theme? It is. Almost every one of them has the same basic flow. Okay, so now I've got to find quadratic equation time. So what is the quadratic equation of this? Okay, so it is b is 6, c is 12, and I got to come up with what is my answer. So it is, which is equal to what? Is equal to a over s. So this is equal to 20, right? 20 over this. So it's 20 is equal to a over times k over s plus 3 plus minus the square root of 3j plus k star s plus 3 minus square root of 3j. All right? And from that, you solve, you get 20 is equal to a times s, okay, a times s squared plus 6s plus 12 plus k times s times s plus 3 minus square root of 3j plus k star, and I'm not going to write it out because you know that it's going to cancel out. So basically I come up with that answer, and then I get my a. Let s equal 0 to find a. A is equal to 5/3. Let s equal minus 3 minus square root of 3j, and that gets my k, okay? So with that in mind, my k is equal to 5/3 at angle 120. Excuse me, it's angle 120, not square root of 120. Okay. Final answer, 5/3 plus 2 times 5/3 e to the minus 3t cosine square root of 3t minus 120 degrees. Okay, any questions about number 3? Do one of these now that you kind of looked these over and seen how they're not hard. They are complicated by the mere fact that there are a lot of steps, but there's a pattern involved, and it's not hard. It just takes a lot of steps. You have to be able to go through a lot of steps. So again, I don't want to say it too many times, but they're doable. They're not easy, but they're doable. Number 4. Okay, so this one is, now you can't. Now you're forced to do the 1 over 1 over rule. So this is the dividing line between the earlier one and this one. Now, in this one, number 4, you must use the 1 over 1 over rule. So first thing you got to do is you got to find the resistance of these 3. Okay? Then you use voltage divider. But that's being said, this is not easy, but this is 1 over 4 plus what? 1 over 4 over S, or S over 4, plus 1 over S for your inductor. Okay, so this comes out to be 4 over 4S over S squared plus S plus 4. Okay, so that's that part of it. So now what do you do? Well, now you've got to, now what you got to do is do voltage divider, and I missed this one as well. So again, what do you do here? You say my V out is equal to 24 over S times 4S over S squared plus S plus 4 over 4S over S squared plus S plus 4 plus 2. Okay? Everybody agree with that? Everybody see that? So I missed it. So again, I've got to go back and do this. So what do I have to do here? I have to say, okay, in order to get this 2, it's plus 2 times S squared plus S plus 4 to get it, okay, or S squared plus S plus 4. All right, so now I've got 4S over S squared plus S plus 4 over 2S squared plus 2S plus 4S is 6S plus 8 over S squared plus S plus 4 times 24 over S. Okay, now these cancel. This is what I've got left. This S cancels with this S. So now I've got 96. 4 times 24 is 96 over 2S squared plus 6S plus 8. What is that equal to? Okay, now I'm on my own because I missed it again. So this is equal to 48 over S squared plus 3S plus 4. Okay, now this B minus 3 plus or minus square root of B squared 9 minus 4AC or minus 16 is equal to what? Over 2. Okay, so it's S is equal to this. So this is equal to minus 7. Square root of 7. So that's this one. And you do not have another S term because it canceled out. So you got rid of the S term with this one. Any questions about this one? I did not finish this one, but this is what it is equal to, it's 48 is equal to K over S plus 3 halves plus square root of 7 over 2J plus K star S plus 3 halves minus square root of 7 over 2J. That's where you, anyway, and that's this one. And I missed this one as well. Okay. And then you find your final answer and you're done. But that's it. That's the only thing you got to do there. Okay. Any questions about that one? Yes, sir.
What is the final answer?
I do not have it because I missed it. So I'll give you credit for it. See me afterwards, I'll give you credit for it. I will give you credit. That's why I'm doing these today, because I am, honestly, these last few days have flown by, and if you see that you got it and I didn't, this is how you work it. I know that's how you work it. It's just, yes, sir.
Can you
Can you use Rule 19 at this point in time?
once he gets
Yeah, you can. Well, you can do it, yes. You can fit it to this, okay? If you want to do that, you can use Rule 19. Yes, you can do that. Yes. Yep. Yeah, you can use, at this point in time, you can just use Rule 19 and you're done. Yes. Yeah. Yep. Okay, any questions about that one? All right, number 5. Like I said, these don't get any easier, but I don't want to be fair. Okay, so this one is a lot easier. Why is this one easier? Voltage divider, but you do not have to, you basically can write this straight out without having to do any 1 over 1 over rules, because you don't have to combine anything. So this is equal to what? 15, okay, voltage out is equal to what? 15 over S times 6 over this whole string, 5 plus 2S plus what? 4 over S. That's it. Okay? So, again, you can probably, with this one, use the Rule 19 as well. I didn't think about that. No, you can't, because you got the A. No, you can. You can. It's there. You can cancel it out. So it's equal to what? Well, let's leave this 15 and the 6 all alone and get the denominator. So it's 15 over S times 6 over 5S plus 2S squared plus 4 all over S, the denominator. So this becomes the numerator, so this flips up to here, and these cancel out. So now you've got basically just 15. Okay, now you can look at the 5S, and this becomes a 15 becomes a 3, and this becomes a 1. So it's 18 over S plus, no, I don't want to do that. I don't want to do that. I want to, okay. So it's equal to, I'm going to redo this, it's equal to 15 times 15 over, it's 15 times 6 over 2s squared plus 5s plus 4. So now I'm going to cancel the 2, and then it's going to be 5 halves plus 2. So it's going to be 3, and it's going to be s squared plus 5 halves plus 2. So it's equal to 45 over s squared plus 5s over 2 plus 2. Now, you can use Rule 19 on this one as well, okay? If you want to, but this one turns out to be minus b minus 5 halves plus or minus square root of b squared, which is 5 halves, minus 4 times a times c times 2. So it's 5 halves squared This is minus 7/4, so this is equal to a minus 7/4. So it's minus 5 halves plus or minus, okay, minus, I missed this one, plus or minus j square root of 7 over 4 over 2. So that gets you your final answer. But that one's also this one's easier up here, and then you get to this point, and then you get to this point, and then you finish it off. S squared plus 2.5s plus 2. Okay. Right. Any questions about that one? Yes, sir.
Is the 6 ohm resistor also in the denominator?
There's what?
Is the 6 ohm resistor also?
I still didn't understand you. Is there a what in the denominator?
It's the resistance of the 6 ohm divided by the 6.
It's just oh yeah, I didn't put it. Yeah, I should have put it in there. Yeah, sorry about that. It should have been 11. Yeah. Yeah, I'm sorry. It's 11. I'm sorry. Daggone it, I'm messing up pretty good today. Anyway, yeah. So it is. Yeah, let's go back and do it. Right. All right, so here we are at this point in time, and we got to get back and get the right answer. Okay. Again, if you got these right up to this point and I missed it, I'll give you credit for it. I don't want to if anybody certainly last couple of days I've certainly not been anyways, beside the point. Okay, so it's 15 over S times 6 over 11 plus 2S plus 4 over S. So I have two S squared plus 11S plus 4 over S, and that S comes up here, and those cancel out. So now I have 16 times that, and I can cancel the, this becomes a 3, this becomes 11 over 2, and this becomes a 2. So now I've got 45 over S squared plus 11 over 2S plus 2. So that gives me, yeah, and that made it correct. Okay, that's what, yeah, there you go. So now we have 11 over 2S. So now it's minus B minus 11 over 2 plus or minus square root of B squared 11 over 2 squared minus 4 times A times C all over 2. So this is 11 over 4 plus or minus 11 over 2 quantity squared minus 8. 89 over 4. Which is a real number, which is 2.358. So this whole thing here is 2.358, and that's correct. So it's 11 fourths plus or minus 2.358. So your answer now is equal to A, and this is right, A over S plus 11 over 4 plus 2.358 plus B over S plus 11 over 4 minus 2.358. And that is equal to 45. So 45 is equal to this right there. And your final answers are whatever they are. So now you've got A, you got 45 is equal to A times 0.392 plus B times 5.108. And what? So right, I got, is this right, to 45? Is that right? So what you got? Okay. Well, if that's right, then Okay. I think the final answer is about 9, or it's about 9 times e to the minus 5.108 plus about 9 times e to the minus 0.392 t, in that range. Okay. Anyway, they're rough. That's what I got. Number 6. Number 6. This one is really the weirdest one. And the way to solve this one is the way to solve this one is this. Okay, so what is the resistance down this leg? It's 10 plus S. What's the resistance on the other? It's 10 plus 2S. So what is the resistance of all this? It's R1, R2 over R1 plus R2. And if you can find that, then you can use voltage divider, because it's just that clump over, it's that clump over 10 plus that clump times 100 over S. That's it. So how do you do that? Well, it's 10 plus S times 10 plus 2S over, what is the addition? It's 3S plus 20. So what is the numerator? Well, it's the multiplication of this. So it's 2S squared plus 10S plus 20S plus 30S plus 100. 10 times 2S is 20, 10 times S is 10, so it's 30S. That whole thing over 3S plus 20. Now, you can't cancel yet, but let's look and see what you got to do. Now all you got to do now is say, okay, so what is the voltage across the output? Okay, the voltage across the output is 100 over S times 2S squared plus 30S plus 100 over 3S plus 20. That whole thing over 2S squared plus 30S plus 100 over 3S plus 20 plus 10. Okay. Now, this is dirty, but it's doable. What is this 10? It's equal to what? So you got 100 over S times 2S squared plus 30S plus 100 over 3S plus 20 all over. So this is 30S. So now instead of having, so 10 times 3 is 30S. So I've got 2S squared plus 30S is 60S plus 10 times, this is 20, is 200. So now I've got 100 and I've got 200, so I've got what? 300 over 3S plus 20. So everybody see how I did that? 3S times 10 is 30S. Add to the 30S gives you 60S. 10 times 20 is 200. Add to the 100 gives you 300. Now these cancel. And now you've got something you can actually use. So this is my voltage across my output, or I call it my VA. My VA is equal to 100 over S times 2S squared plus 30S plus 100 over 20S squared plus 60S plus 300. Now I divide that by what? S, to get I1, it's 10 plus S. So I put a 10 plus S in the denominator, and that's my I1. My I2 is S plus 2S plus that. Now, how do I get my answers here? How do I physically get through this thing? Well, I look for factorability if I can find it, but if I can't, I do some canceling, and but it's doable. This is my I1. My I2 is 100 over S times 2S squared plus 30S plus 100 over 20S squared plus 60S plus 300 times 1 over S plus 2S plus 10. And I start canceling, and I get my answers. This was the worst one of them all, in my opinion. But that's how it's done. Canceling and working through it, I should never have asked this question. I will never ask this question again. How's that? But this is how this problem's done, in my opinion. Okay? Why would I not go with the two-loop method? Because if you did, then you would have to add the two together, because you have to subtract the I1 minus I2 here. And I didn't want to do that. I can find my I2 over here, and that would have given me my I2, but this method gives both of them clean. Okay, in other words, they're both doable. You can do it with the loop method, but I believe this is probably the quickest and easiest. Now, these two are mesh analysis, and I want you to be able to do mesh analysis with this stuff. So, again, we'll see how you do. Not easy. All right, number 7, number 8. Okay, so with these, it's basically writing the equations and then so for this one, it is around the first loop, it's minus 24 over S plus I1 times 6 plus S plus 4 plus I2 times minus 4 is equal to 0. Around the second loop, it is I1 times minus 4 plus I2 times I2 times 4 plus S plus 8 equals 0. And you sort and sift, and a lot of you did not find the I2. Okay, so So the equations here are this. It's I1 times 10 plus S plus I2 times minus 4 equals 24 over S. I1 times minus 4 plus I2 times S plus 12 equals 0. Okay. So, how do you find I2? I2 is equal to, it's the S plus 10 stays, the minus 4 stays. Instead of the I2, you put 24 over S in the 0, and that's your determinant in the numerator. In the denominator, it's S plus 10 minus 4 minus 4 S plus 12. And then you cross multiply. It's this minus this, this minus this. That's your I2. You got them in the wrong column, okay? You got to get, the column you want is the I2 column. So you take out the numbers that are in the I2 column and you put in the number on the right side. That's what you missed, okay? I saw that again and again and again. So I want you to understand that this is the right way to do this, okay? So what did you get for a final answer? Whatever. It's I got minus 12 over 13 plus 2 times 0.382 e to the minus 11t cosine square root of 17 t plus 29 degrees or thereabouts. This is what I was looking for. If you can get it to this point, you can finish it off. If you can get it to this point, it's easy. But getting it to this point is where most of you messed up. And I know we didn't practice this a lot, but this is what I want you to be able to do. I mean, this is what at this point in time, my influence over you has waned. You can take me or leave me. But as far as what you're going to have to do if you ever do this again, I owe it to you. I owe it to you to tell you what you need to be able to do, because this is what will get you a PE, okay? This is not guaranteeing you a PE, but this is what will help you get a PE if you want one. And it's what I owe you. This is this cross multiplication, but you have to substitute in the right column. The column that we wanted was the I2 column, which was this column. So you have to take the numbers that are in the I2 column out, and you put in these numbers instead, okay? That's what Kramer's rule is, okay? That's all it is. So again, it's S plus 10 times 0. Pray for zeros. And then minus this, which would be a minus 4 times 24 over S, which would be a plus 4 times that, which would be 96 over S. So you equal 96 over S over, what is this? S plus 10 times S plus 12 minus a minus 16, which would be a, or minus a plus 16, which would be a minus 16. So you do that, this whole thing, and you go to war with that, and you're done. Easy peasy. No, it's not. It's doable. Okay? The other one is the same exact problem, except for now you got all these stupid voltages in there, because now you've got to put in what? Initial conditions. So here's where the initial conditions raise their ugly head. You pre-charge everything, this one and this one, to 12 volts. So you basically have to put in a voltage supply that is 12 over S. Okay, so now what you go to war with is this 5 ohms, and this is, and then you've got a voltage, you've got a, which is a 0.5 over S plus a voltage supply here of what? 12. 12 over S with the plus up. Okay? And you got another one over here with a 2 over S, another capacitor with a 2 over S, and another voltage supply plus to the left, minus to the right with what? 12 over S. And then you got your 3 ohms. And away you go. 2 loops, I1 loop, your I2 loop. What do you have to solve for? Solve for I2. I2 times 3 is your voltage across the is the voltage across the 3 ohm resistor. That's it. So if you find I2, you're in. So basically what do you have to do? Well, it's 5, 2 equations, 2 unknowns. It's I1 times 5 plus 0.5 over S plus I2 times minus 0.5 over S. And then it flows plus side up plus 12 over S equals 0. I2 loop come in from the minus side, so it's going to be a minus. This one's going to be a minus. This one's going to be a plus. So the I2 loop is going to be an I1 times minus 0.5 over S plus I2 times 0.5 over S plus 2 over S plus 3. And then I've got a minus 12 over S and a plus 12 over S, so they cancel each other out, so it's equal to 0. Now you've got everything you need in order to find the final answer. So you move this over to the other side. So you move this over to the other side and make it a minus 12 over S. Scratch it out there. So what do I have? What is my I2? My I2 is equal to what? Five plus 0.5 over S minus 0.5 over S minus 12 over S and 0. All over what? 5, excuse me, that's, 5 plus 0.5 over S minus 0.5 over S minus 0.5 over S, 2.5 over S plus 3. This times this, minus this times this times this, minus this times this. There you go. Then you multiply that by 3 and you got your voltage. Easy. No, it's not. But that's how it's done. Any questions? Any comments? Probably hate my guts. Life. I'm just the messenger. I'm not trying to beat you up.
Final is Monday morning.
Yeah, final's Monday morning. What's going to be on the final, right? I'll pick one from this test. I will not pick more than one, okay? I'll pick 4 from the first test, 4 from the second test, and 1 from this test. I'll give you 10 points free, okay? I won't tell you which one I'm going to pick from this test. It will not be number 6. How's that? 6 was the Burley one. I honestly, I should never have picked number 6, but I did.
You want to send it?
About which one I pick or whatever? No. You got, so Wednesday to hand in all homework, anything that you have left that's not done, and I'll get your stuff graded. 4 from the first test, 4 from the second test, 1 from this test. Is that fair? I'll just change the numbers. I'll take the same, I got these on a file, I can just flip, put them in there. I'll change the numbers around, and all you got to do is study the test. All you got to do is study the test. But in this one, I'll not tell you which one. It probably will not be one of these last, it will not be 6, 7, or 8. How's that? It'll be one of the first 5. I'll give you that much. I'd like to see you all get 100 on this test. I really would. I don't have any high expectations like that's going to happen, but on the other hand, and I'm an easy grader, you know that. So, and I grade on the curve, so you know that. Any questions anybody's got? Yeah, it's going to be open like this one was, yeah, yes, open note. Bring as many notes as you want. By the way, multisim. We did not even talk about multisim in this class, did we? No. Why didn't we talk about multisim? You can get the answers to all these questions using multisim. Why didn't I not talk about multisim? You can't use multisim on the PE test. Okay? You can't. So why give you false expectations like, I know you can get the answer and then you can backfeed from the answer and look at it and figure it out and whatever, but it's a attack from the front and get them and then walk away, and then at some point in your life, if you want to do this, fine. If you don't want to do this, it's up to you. Walking through a factory. I said, how on earth did they do that? And I was able to figure it out based on this course. All right? How did they get, starting with DC, how did they get high frequency heat into that metal? How did they do that? This course, this answered it. It did. It really did. I want you to understand that this gives you some insights that you might not have otherwise had, and you may not think you have them, but you do. Whether or not you're getting the right answers all the time doesn't mean that much to me. I understand that if you wanted to, I think a lot of you have the ability. I know you all have the ability, and I'm telling you, most of you could, but you've lost interest or you've kind of tuned me out. But on the other hand, if this was a freshman class, you'd all walk out here and say, I never want to do this again. You're kind of captive to me, and you got this to get through before you get through EET. You can be at a bar someplace and somebody who's an electrical engineer says, oh, you're just an EET. You can look back at them and you don't have to say a thing. You went through many of the same things that they did. This is the same stuff that they hit, and it hits them just as hard as it hits you, okay? Don't believe anything other than this ain't easy, it wasn't easy for them, it isn't easy for you. These are multi-step, many long problems. You have the ability, if at some point in your life you want to get back and do the PE test, you have the skills, and that's all this is. End of story. I know it works. It happened for me. I know it can work for you. You're not any different from me, okay? You just have to buckle down, work a month or two hard, work on these problems like this, and also some economics problems. And you'll walk in there and get a good grade. You got to pass the fundamentals test first. The fundamentals test is not easy either, and it's not on this stuff. This is the harder one, but there's a lot of them, and they pepper you. So they're anyway. But all that being said, you got the skill set. See you Monday. If you see something you want to get adjusted, see me, and I'll